had a feeling a talk like that might start some discussion, which was good. Okay, so we've got one more talk before I let you have some food, as I promised before. So up next, we've got Christopher Pitt. He's a really cool developer. He's an active member in the PHP League of, what are we called? The PHP League. I'm trying to remember the name of it. He's an active member over there. He runs a few projects, and he's currently working at Braintree. He's a South African, not Braintree, sorry, Silverstripe, the CMS, sorry. How embarrassment. I was thinking Silverstripe, I've even got it open on my iPad. All right, and yeah, he's from South Africa, and for some god-awful reason, he's gone to New Zealand, but probably because he's gone to work with Silverstripe. So please welcome Chris, who just ran away. So I do that to people. Cool. Let's all make him feel awkward while he walks up by staring.
Thanks, man.
All right, there you go, mate. Thanks, guys.
Hi, everyone. I'm Chris. I work at Silverstripe, and I'd love it if you could all please stand up. Yeah. So I'm not going to take photos, but we're going to get the blood flowing a bit. And to start off, we're going to do some squats. Yeah. Air squats. So it's very simple. You just, up and down like that. We're going to count to 12, do 12 of them, and you can all join in. Let's go. 1, 2, 3. Come on, guys. 4, 5, 6, 7, 8. Yeah, getting into it, Ben. All right, that's cool. All right. Cool, have a seat. Thank you. Cool. Right, so my talk today is on asynchronous PHP. But before I dive into a lot of code and cool libraries and things, I want to talk a bit about the difference between those three things. So who here understands the difference between synchronous and asynchronous? OK, cool. Now, all the things I'm going to explain, you will typically have referred to as asynchronous, but actually most of them are parallel. And there's a bit of a difference here. So let's look at what that is. A typical web request through Apache or Nginx to mod PHP or PHP FPM looks something like this, possibly. So you get an HTTP request in. You do some database stuff, maybe return results to show on a homepage or log someone in. You render a template, and then the response gets returned. And at each point, at each one of those arrows, you're waiting. So once the request comes in, you wait for all those things to happen, and then the response comes, and you can return. And some of those things, like querying a database, can take some time. As Rasmus pointed out, most bottlenecks with PHP aren't actually PHP itself. It's using third-party services. It's reading or writing from the file system. It's querying the database. And a lot of that waiting time is just waiting time. It's not actually doing anything meaningful. What async is using that waiting time to do other small things. And this usually can happen through things like event loops, where processes will be run, and each tick will do a little bit of work for a separate process. But actually, what we really want is parallel processing, and that's things like running processes on separate threads, where you're not running in a loop, you're not waiting, but things can happen at the same time, processor-wise. And before you think, well, OK, let's start doing some async stuff, which, by the way, I'm going to say async to mean both async and parallel processing. Before you think, OK, well, let's look at what this async thing can do for my application, you need to ask yourself if it's something that you need to fix with async. It's more work to do asynchronous and parallel processing in PHP than it is just the traditional top-down synchronous means of doing it. And hardware is a lot cheaper than developers. So if you can scale your application to serve more requests by adding more servers and load balancers and caching, do that first, because it's cheaper and it requires less learning, and that's cheaper. Right. The first async thing, or indeed parallel processing thing I want to talk about is queues. So I've got a few code examples to check out the stuff. It's a really cool projector. Okay. Now, there are a few, let me go back here. There are two different flavors of queues, message queues that we're going to look at. But they both work in this sort of way. So a client PHP script creates a task, usually has to connect to a server to send that task to the server or the manager. Now this can be either a daemon running on a local system or running on another system in a local area network, or it can be a web service. And that web service or daemon delegates the task to a worker script. And then the worker does the task. So forms of daemons for this kind of thing are Beanstalk, RabbitMQ, and ZeroMQ. You've probably heard about these at some point, maybe not worked with him. That's cool. We'll look at how to do stuff with queues. And kinds of services, IronMQ and Amazon SQS, probably also heard of them in drips and drabs. It's a similar thing. So you have a client script, makes a task, sends it to a manager, and then a worker script does the thing. All of the daemons and libraries and extensions that I use are installed on this machine with Homebrew. So if you want to know how to dig into this stuff and you don't know how to install, go and install Homebrew from here. And then Homebrew lets you do really cool things like brew, search, Beanstalk. And it'll tell you what packages are available to download. So if you've got a brand new Mac and you don't have the extensions required to be able to do some of this stuff with PHP, or know how to install different versions of PHP, and you don't want to run VMs particularly, for various reasons, then you can usually find what you want to do by brew, install PHP 5.6, whatever the name of the extension is. In this case, what I needed to do was install Beanstalk, but I've already got it installed, so it'll tell me that. And because it's a daemon, I'm going to have to run that. So conference Beanstalk D. So now this thing, this daemon is running in the background, and so any time I connect to it with a client script, it'll send the tasks there, and that'll get it to, that'll hold the tasks until a worker connects to it, does the task, and is done. To have a look at what this thing looks like, I've downloaded a monitor, so Beanstalk CLI, monitor. And that tells me that there is currently one connection, no idea where that connection's from, but no jobs, no workers, and no producers yet. So I've also downloaded a library to be able to send tasks to this Beanstalk daemon via PHP. You can do that. If you've got Composer installed, by Composer install PDA Beanstalk. I'm not going to do that, though, because I don't want it in my source folder. Whatever. OK. So the client script I spoke about, well, this is what a simple one looks like. It starts, it connects to the daemon at that address, which is just my local machine, uses a tube conference, which is like a channel of tasks, and puts a job into that. So if we run this thing, client, and we go back to the monitor, then we'll see there's current jobs ready 1. So it's just waiting there for a worker to come along and do this. We can make a worker script, which looks like this. So again, we connect to the same daemon. We watch the channel, or tube in this case, that the tasks, we know the tasks are going to be in, and we reserve whatever tasks come up. So now, since we've run the client to send a few tasks, I'm just going to send quite a few in there. We can see now we have 6 jobs ready. And if we do this, what did I call this worker? It processes 1 task. So it gets the first task it can off of the queue, just renders out whatever data is in there, and deletes the job. We could run this in a loop if we want, with some sleeps. But I'm just going to run it a few times. Yay! And at some point, it's going to run out of tasks to do and wait for the next one. See, now we have no jobs ready. That's pretty cool. So what then? OK, client, worker. Queues are one way. Message queues are one way. Because you could be sending to a daemon or a web service, and the process of waiting for a response from that would be blocking, most queues are implemented in a one-way fashion. So the client script will add some tasks to queues and not really care about what happens with them, whether there are errors in there, whether they're finished processing, and when they're finished processing, it'll just fire the task off. And the daemon or the manager will have to deal with what that does. So it is not practical, feasible, for you to fire up a message queue and say, for instance, issue a task to send an email and then wait for that email's response, wait for the response of the server to send that email. It's not possible to do that. So let's move on. Gearman. Now, Gearman is a very similar concept. You'll notice that this does, the first three steps are exactly the same as queues, except that there's a fourth step where we can actually get feedback back from the worker to the client that issued the task. So if we look at what code like that looks like, yay! Losing cursor. I didn't want to do that. Okay, so we have a client. It adds a server. Now that's the daemon that it'll connect to. We can set some. I'm so lost here. Hold on. Okay. Now, get there. Where has this gone? Ah. That full screen API, hey? Right, so we have a new client script, connect to a server. We can add things like completion callbacks and progress callbacks, and start callbacks even, and do stuff within that. We'll modify this in a bit. But the idea is the same. You make a task, and then client run tasks just says to the daemon, well, fire off any of these tasks that need to be done. So if we run what this looks like, we can close this now. This also needs a daemon, so you can install it with brew install Gearman. Like that. You'll also need a PHP module for this, which you can install with Homebrew as well. But that means that the functions are available without having to load in an autoloader, which is why you don't see a composer autoload statement there. Now, if we run Gearman, there's no monitor for that at the moment, because I couldn't find a cool one. But that's running. Take my word for it. I'm going to make that spelling mistake forever. Okay. So we create a client, and what that we run this client script. And so what that does is adds the callback, adds the task, and because we've said run tasks, it's going to wait there until that task is actually complete. So we can go into a similar worker. But before I run that, let's look what the code looks like. Again, we connect to a server. We add a handler function for that task, which is named exactly the same as what we call the task there. And then we do something with that. So for now, I'm just going to say in worker, so you can see it happens there. And we have an infinite loop. So this worker just stays running in memory, long-running script, and processes tasks to it as they come through. So when we run this, we've got, let's have a look here. So the client died because the client sent a task, waited for the completion, and then once the completion callback fired, the script was done. So we can keep doing these now. And because there's a worker running in memory, it's processing those. Yay. Without new lines, of course, because new lines are illegal. But we can complicate this a little bit just to see what it's actually doing. We can say something like for each range 1, 5 as I. That looks fine. Yes. Okay. So when we restart that worker and fire off a few more tasks to this, we can see the worker is now doing something. Yay, although you guys can't see because it's blocked. So sorry about that. Yeah. Cool, eh? Right. So both this and queues are parallel processing because the worker is doing stuff in a different thread to what the client is doing when it's issuing tasks, and that's pretty cool. But the more astute of you may notice that this is synchronous. So what I'll do here is, I'll do that, and I'll restart the worker, not that I think I need to. Oops, that's kind of synchronous. So by default, the Gearman extension runs these things synchronously, and it kind of has to because of the callbacks. There is a way to add tasks to execute in the background, but the moment you do that, the callbacks don't work. So that's a bit of a problem. We'll look at ways to get around that much later on in the talk. But Gearman, hey, Gearman, guys. Yeah. Callbacks run synchronously. Background tasks are just like queue jobs because the callbacks don't work. So they're not just like, but they're similar. You can find out more about this stuff at gearman.org, which is where the daemon is, the PHP manual for it, and then another project I'll talk about just now. React PHP. Now this is the most exciting thing ever. So I'll let you guys just soak it in for a couple seconds. React PHP. React PHP is a PHP project which implements, amongst other things, it's a collective of projects which implements, amongst other things, an event loop. So hands up if you've worked with JavaScript. Hands up if you've used functions like add event or add event listener or onClick. Right. So what powers that stuff in JavaScript is a browser-based event loop. Now, React PHP implements that kind of thing. It does it via a number of different processes. So if you have certain extensions installed, like the PHP bindings for libevent or libev, then it'll use those. Otherwise, it'll use PHP's inbuilt stream select stuff. Long story short, you'll be able to run applications like Node.js. Similar structure. But async, React PHP is not parallel. So event loops in general are asynchronous but not parallel. They execute a bit of something one at a time. It's not separate threads. It's not things like message queues or things like Gearman, which you can run separately to the main thread. Event loops will run a little bit of something, but only one thing at a time. It's the same in JavaScript and Node.js. But the last time I gave this talk, someone gave a really snarky comment about it not actually being asynchronous. And the thing is, there's a very clever guy called Joe Watkins who explains the difference between synchronous, asynchronous, and parallel. I'm not going to give you the link to that right now because then you'd all go and read that, and it's much cleverer than the rest of this talk. But maybe I'll give the link on Twitter, and you can check it out. Bearing in mind, event loops aren't truly parallel processing. They're just asynchronous, but it's still really cool. Lets you build things like HTTP servers as what you might be used to if you worked with Node.js. Also, just to note, React PHP is still in beta. I say that. It serves some pretty big stuff the world over. I think beta is just a safety precaution on their part. It's not an extension, so you don't actually have to install anything extra to get this to work. You can just compose a require React PHP, and it'll work, which is pretty cool. I mean, you'll have to write some code for it, but you don't have to recompile PHP for anything or install extra extensions. It's not a framework, so if you're looking for a replacement for your Symfony app, well, you'll have to build it all from scratch. It's just a lot of really cool components. There are things in there like socket clients and socket servers on which the examples I'll show you are built. There are things like a promise implementation, so A+ promises in PHP, really rad stuff. Okay, code. Got some more examples. So setting up a React thing is pretty simple. You create the event loop I spoke about in depth, a socket server, and an HTTP server which decorates that socket server. Add some event listeners, and this event listener will fire on every request. It's not going to discriminate between requests to different things. You'd have to write that yourself. Tell the socket which port to listen on, and then run the event loop. This results in an infinite loop. Because it's an event loop, guys. So it doesn't really look like much is going on there. But if you go to localhost 8080, well, hey, very small hello world. And that's because in this, we're saying on every request, set the content type to text plain, and end with hello world. Now, this code is very, very similar to if you've ever built Node.js apps, which is why I like to refer to it so much. Sorry. But you have useful functions here if you want to do more complex stuff, like you can print the request get method, or even get path. I'll actually have to response write these, because otherwise. I wish I was a Vim user. Yeah, broken. Do a live demo, they said. Yeah, get and / I guess. So we can do something more interesting like blah, 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 blah. And that renders blah with the get method. So it's your job, if you're writing an HTTP server in React, to manage this stuff, to add a router in, to handle different methods. But this is a really good basis to work on. And this is like a replacement for the traditional PHP mod PHP and PHP FPM stacks. So that's pretty cool. The server is a long-running script. The moment you run that event loop, it goes into an infinite loop. And that is so that it can keep on checking for event listeners that it needs to fire. Any errors, any fatal errors in your code will kill your whole application. You can mitigate this kind of thing by splitting your application up into to listen on different ports, or having different parts of it listen on different ports, or running load balancers and running this as a daemon. Really up to you. But bear in mind, this isn't, if an error happens in any of your writing code, well, the whole server is going to go down, because it's just a long-running script. Timeouts don't apply, and this uses the PHP CLI INI file. So try debugging that if you don't know. There are some really cool places to learn more about this. So the first link is like a series of blog posts on different things in React PHP. I encourage you to look at that later, like after the talk. And the other is just to see some cool things done with React PHP. On top of this, Chris Bowden, who contributes to React, builds another library called Ratchet, which is pretty cool. More code examples. Sorry, guys, nearly done. So this code is slightly different. In fact, it's very different to the React-based code, but let's have a look at what it does. To begin with, Ratchet is also a collection of different components. The most popular and common and widely used one is a WebSocket component. So if you've done any WebSocket work with something like Socket.io in Node.js, this is going to be really cool for you. If you haven't, you really should. But the idea here is that we set up a custom class which catches these events. So when a WebSocket's opened, when a message is received, close, or error. And we do stuff at that point. Then we decorate a whole bunch, because React and Ratchet are all about decoration. And this will give us, when we use server run, that'll start the event loop in the background. And at that port and IP address, it will run a server, which is pretty rad. So I'm going to run that quickly, and we can see what that looks like. Yeah. So this is another another silent script. But we can check out what's going on in the console here in very small type. Because this client file that I've set up opens a WebSocket to the same server as Ratchet's listening to, adds to event listeners. So when the connection's opened and when a message is received. And because this is a global variable, very small console text. When we connected, when we open the connection, I wrote something to the console. And when we receive a message, I write something to the console. And if we look at the server text, when a connection's open, it sends some text to that as well. So the culmination of all of this jumping around is that we have 2 socket messages here. And if we look at what that socket variable is, it's just a WebSocket, which is supported in all the browsers you should be using and none of the browsers you shouldn't. And you can send things to this. So you can say something like socket send hello server as a string, of course. That doesn't return anything, but if we go back to the console, hello server. Down the bottom there, guys, can you see? I'll send a few times because it's still going to be down the bottom because I forgot the new lines. But there you go. That's socket communication between the server and the client. Minimal JavaScript. So if this kind of thing has ever scared you off from doing WebSockets in PHP, really shouldn't, because there's very little there. If this kind of thing has ever scared you off, well, it shouldn't, because if you'd seen how easy this was, you would have done it by now. But the basic idea is that building on React PHP, Ratchet implements this thing where we can now in PHP use WebSockets, where before we couldn't. And if you ever see posts on Stack Overflow or Reddit about how I do WebSocket, PHP application, help, guide, please, then you'll notice that almost every comment to that is, well, you should be doing it in Node.js. Rubbish. Rubbish, guys. You can do this in PHP. You've obviously got to pick the right tool for the job, and if PHP just doesn't cut it and you want to be cute and use it in PHP, well, that's a different question. But for small stuff, for experimental stuff, to try it, you know, research and have unit tests and you'll be fine. No problems. No problems. So that's sockets, hey? We looked at all of that. The link to find the documentation for this, one of the coolest links I've seen is Socket to me. So go check that out afterwards. But you have to ask yourself, why bother? Why bother learning this kind of parallel or asynchronous PHP stuff? A few reasons. I've split them up over slides. High concurrency. So the main benefit that you will get from doing parallel or asynchronous processing in PHP is that you'll be able to serve more requests in the same amount of time. The reason for that is that you're not doing a synchronous request anymore. You're not waiting for task, 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 and then responding. You're letting the long-running things run while you serve other requests. In the case of message queues, you're not even incurring any time penalty beyond sending the task off to the daemon. So it's going to save you a lot of scaling issues when you're trying to go for higher concurrency. But higher concurrency doesn't mean your application is going to run faster. If your application is tanking because server resources are flatlining, well, it might make your application run a bit faster just because it will save some processing. But running more of a thing doesn't make that thing faster. Being able to serve more requests per second isn't going to make your app faster. So that's not a reason to do this kind of stuff. Learning new language paradigms is great. So if you haven't done this event loop-based stuff, it's pretty awesome. And event-based code can be used to make cleaner code. I say it can be used because there's always going to be someone who abuses and messes up the whole thing and says event-based code sucks. So I hate you, person who does that. Async is useful. So in the example of sending emails or doing things in the background, async is actually pretty useful. Parallel processing, pretty useful, because you're not incurring the waiting time. You can delegate stuff that's not required for a response to a background process. You can farm those background processes out to different servers and server farms. It's pretty useful. And because it's useful, it's being used in a lot of popular frameworks, including Laravel and Silverstripe, where I work. Honorable mention to pthreads. So Joe Watkins, the guy I spoke about earlier, has this extension for PHP, and it's a pretty awesome extension, but I'm not going to show code to do it because I've got 5 minutes left. Some other interesting projects, I'll have a look if there's time at the end after questions. No, I'll look first because you guys can ask your damn questions afterwards. Right, so Homebrew I looked at. This is the CLI application I use to monitor the Beanstalk queue. Probably not that meaningful to you unless you do this. React Gearman. So the task of sending a task to the Gearman daemon is a blocking task. It's a synchronous task. This very smart guy has created a library to be able to send tasks to the daemon and pull tasks off the daemon, the Gearman daemon, asynchronously. So it uses all of React's HTTP client stuff and DNS resolution stuff to find the daemon, to send the task to it. So this is a pretty cool project. Pretty useful if you're using Gearman. Right. This is the thing I worked on recently. And what this is a distributed event emitter, which is pretty fun. But what that means with my Zoom level is that you set up an event emitter. If you've not used the League event emitter, you're a fool and you'll die young. Use the League event emitter because it's amazing. But what this does is you attach it to a socket and you give it the emitter, and then you can add events and emit events, just like other event emitters, and listen on a special port. And then the client, after all this massive setup, can actually emit those events on the server, which is pretty rad. So in the case of doing something with Gearman where you don't have the callbacks if you do it asynchronously, if you use this kind of thing, you can still give progress and completion callbacks to the server and have it do background tasks. That's pretty rad. That's pretty cool, eh? So remit. I built that because of this thing which I was building, and the idea is to be able to send tasks to a background process and to get the feedback back from that as kind of an abstraction library on top of Gearman. And this is called Assistant. Yay. So I'll put links to this on Twitter later. But let's have some questions.
I was wondering, how do you handle long-running processes, particularly cases where PHP may eventually run out of memory?
So the question is, how do you handle long-running processes? That's a very good question. I don't know if there's a very clear-cut answer to that. The idea of building stuff in an event loop, it's the same kind of challenges you have building stuff in Node.js. You have to optimize to reduce memory and clear out memory as quick as you can, and run things as daemon processes as much as possible. So with supervisor or whatever, just keep on rebooting the script if it dies, which is a horrible hack. But this isn't a problem specific to React PHP, so don't let that put you off. Just be efficient with memory and make sure that there's a plan if it falls over.
I've been using React PHP and made a web server like the one you demonstrated. One of the frustrations is it only supports, doesn't support persistent connections for HTTP requests. So I've observed that you get maybe in hundreds of requests per second versus thousands of a couple of thousand requests per second. It's more of a comment, but if you had any influence on the developers of React to approve my my code that I submitted, that'd be kind of handy because I've got a personal hack at the moment.
Just tweet at me so I can redirect it.
Yeah, cool.
Yeah, the thing is with React PHP, it's a collection of libraries, so they have a really neat socket server and socket client. It's possible to reduce the time that long-running requests run and to farm out a lot of that work to other processes or using WebSockets to do a bit more like a bit more push and pull of data on the client.
Well, the features are there. It just needs
yeah, it needs polish. Yeah. Thanks. Any other questions?
What do you think of PHP rescue?
To be honest, I haven't really used it much.
That's bad.
Yeah. Sorry.
Are there solutions? Are there solutions for stuff like MySQL integration, like where you can offload like make the actual connection an asynchronous thing?
So the trouble is that, and I speak under correction with Rasmus in the room, that the goal of PHP it didn't begin as a big complicated programming language, and certainly not with asynchronous stuff in mind. And when it happened, there wasn't JavaScript yet. Like there wasn't this evolved concept of using an event loop or doing parallel processing. It was just it's just all synchronous and like built synchronously. There are a lot of asynchronous things in PHP coming into it. So there's a Postgres asynchronous driver, and there's curl async stuff, and that's cool. But you're always going to run into some blocking process. So the React guys are working on some stuff to reduce the blocking, the typically blocking stuff. Like they're working on an async file I/O library, which is cool. But the simple answer is to farm out as much of that to different threads as possible, and to do as little blocking stuff in the request response cycle. So Gearman helps with that, with background processes and something like remit to be able to get callbacks when that's possible. You're still, if you need to wait for the whole, if you need the database results to render the page, you're still going to have to wait for the database results to render the page. But you can be as non-blocking about it as possible with message queues or Gearman or pthreads or something like that. Any other questions? Thanks very much, guys.